This is the tutorial video for pH practice. As for this stuff up here, mostly I would go back and look at this paper up here for reference. Obviously, the answers are here, but a lot of the information could be gotten from that graph or understood from that graph. I want to talk about this for a moment. What we're talking about with this H3O plus business is it turns out that water falls apart a little bit once in a while, but it keeps happening. All water that you've ever encountered is a little broken down, at least a few molecules of it. So that might sound really weird, but it is a big point in chemistry. It's a big point of understanding acids and bases. So an acid is something that gives an H plus, and a base is something that takes an H plus, and sometimes even that can be water. So if we have two water molecules, once in a while, what can happen is that one of them gives an H plus to the other one. It just happens. It just happens. And if you do that, what you get is an H plus extra on a water, and that would be this. This one's this one's missing an H plus, so that would turn into this. Now, then somebody asks, why isn't the H first? And honestly, I don't know, but no one puts it first. And if you want to be the weirdo at college who puts it first, you can be the weirdo, I guess. But honestly, some professors might even mark it wrong. So this is called hydronium, as we said in number 3. And if you put a strong acid into water, all the H's come off. And in this case, the H would come off and it would go onto water, and we would also get hydronium, and then we would get the Cl minus missing the H plus. However, also, what we sometimes do is skip the whole hydronium thing, and we just say this. HCl becomes H plus and Cl minus. And my point is that this is a little bit of a lie, but it's a very useful cheat here. Really, the H plus is on the water, and really it's that. But it's so much more writing, and this is still so useful for the conceptions and especially even for the math that everybody cheats. So when I said on the other sheet that the pH is the negative log of the H plus molarity, even more properly, I guess it should be the negative log of the hydronium molarity, but I've said it so many times this way that I just even forgot. That's how much we cheat with that. So these are the same thing. It's really that, but everybody cheats and writes that. So let's talk about logs. Log means 10 to the power of what will get you that number. So I visualize it sometimes as the box. What's in the box? What exponent is in the box? Log means 10 to the what power, unknown power, will get you this. So what's in the box here? What exponent? And 2. 10 to the 2 power, second power, 10 squared will get you 100. So 10, the box will get you 100. This is what I mean by write out the plain math version, or you could put x, of course. And box or x equals 2, so log of 100 is 2. What's log of 1,000? Well, that means what power, what exponent do we stick on 10 to get 1,000? And 3 is in the box, or x equals 3, right? So log of 1,000 is 3. What's the pH and pOH of this molarity HBr solution? Now, the reason I crossed out Br is that for the purposes of pH, it doesn't matter. And I will show you this list of strong acids and strong bases and interrupt here because it has a real point. Don't bother memorizing this. And for the purposes of the intro class, we will only use the strong acids and strong bases, so you don't have to worry about memorizing the list. We won't make it overly complicated for this year. For AP, we get into a bunch of stuff using weak acids and bases, and then it gets very, very math. So if you had something like HBr, my point is all the H's will come off. If you have 9 of these in water, then you get 9 H pluses breaking off and 9 Br minuses breaking off. So if you could count these, count the moles, that would be the moles of H plus coming off. So if you say there's 1 mole of this, then there's 1 mole of H plus in the water and 1 mole of Br minus in the water. But for the purposes of pH and pOH, I don't really care about the Br minus. It's not going to change anything. That's why I scratched out the Br here. It's not going to matter for the purposes of H plus unless I have to involve grams, which will come up in a little bit here. But if this is the molarity of the HBr, then it's also the molarity of the H plus, and it's also the molarity of the Br minus, except I don't care about the molarity of the Br minus. That's why I crossed it out. I'm going to borrow this number as the molarity of H plus. And then pH is the negative log of that answer. That's what that means. I'm tired of writing out all the numbers. Plus, I'm encouraging you to use your answer key on your calculator if you have one, because it's much easier and it's harder to make a mistake. And that is 2.9. And that is the pH. If you use the H plus molarity, you get pH. And remember that brackets means molarity here. Remember that pH plus POH adds up to 14. Which means if you know this one, you can subtract it out of 14 and get that one. That's what I'm going to do here. 14 minus that answer gives me POH. In 14, we use a strong base. So OH minus is going to matter for pH and POH. I don't really care about the sodium part, so I crossed that out. Remember, what matters for pH? H plus and OH minus. You might write that down. What matters for pH? H plus and OH minus. So this molarity of that strong base is also the molarity of OH minus. Because if I had 10 of these, say, I would get 10 NAs breaking off in water and 10 OH minuses breaking off in water. And that's what we mean by a strong base, that all this breaks up. That's what we mean by a strong acid, all this breaks up, just by putting it in water. So I'm going to borrow this molarity number for this, and then negative log of that answer will give me a value, and that is POH. If I use the OH minus molarity, I will get POH. And 14 minus that number will get me the other one, will get me pH. For 15 and 16, I even put in some directions. What's the pH and POH? Well, what do I need for pH and POH? I need molarity. I need moles per liter. They didn't tell me moles per liter. They did kind of tell me liters. That's going to be 2.5 liters. Remember that milliliters to liters always pushes the decimal left 3 spots. I would write that down. So that's where I got this part right here. What I don't know is the moles, but we have converted grams to moles about 100 times. So I'm going to take the grams, find the molar mass, divide, and I get the moles. Now, also, I know that that's the moles of HI. And when I do the molar mass, I have to include the I to find the real molar mass. But remember, if I knew that this was 15 of these, in water, 15 H pluses would break off and 15 I minuses would break off. But I don't care about the I minuses right now because they won't affect the pH. So when I find the count for the whole thing, I'm just going to mentally cross out the I minus and just count it as the H plus. That means I know the moles of H plus. And that's what I needed down here, huh? And moles divided by liters is molarity. And now I have molarity of H plus, and I can do negative log of that answer. And that gives me pH. And we said 14 minus the one you know gives you the other one. So also, what's the pH and POH? So I add 2 grams of hydrochloric acid until the volume is 5,000 milliliters. Well, what do I need for pH? I need molarity. And this is an acid, so H pluses are going to come off. So again, I take my grams and convert it to moles. And I did that because I know I need moles over liters to get molarity. I already had my liters. What I needed was my moles. So grams divided by molar mass is moles I'm going to cross out Cl minus in my mind because I don't really care. I know this is the number of moles for the whole thing, but it's also the moles for the H plus. I'm going to take that moles over this liters that I was told. Divide gives me molarity of H plus, and negative log of that answer gives me pH. And 14 minus that answer gives me POH. Here are my extra credit questions. So here's a new formula. You have two different solutions. The first one has a molarity and a volume, and we multiply them together. And the second one has a molarity and a volume, and we multiply them together. This is for diluting. When you add water to the solution, and that's what we had in 17. We added water. So I want pH and POH. What do I need for pH? I need molarity. So I had a first situation, I had a molarity, and it had 350 milliliters. Okay, so the first situation had a molarity, and it had 0.350 liters. The second situation, well, I don't know the molarity. I mean, if I had the molarity at the end, I wouldn't do all this. That's what I don't know. The extra little trick to this is that, remember, we added 400 milliliters to 350 milliliters. So now we have 750 milliliters, or 0.750 liters. Now we have an equation with one unknown, and we can solve for M2. What's the molarity at the end when we get done doing this? So this times that divided by that gives you this, and that is the new molarity at the end in situation 2, solution 2. Be careful. What chemical were we using? We were using a strong base with OH minus in it. So when we cross out the thing we don't care about, it's the Na I don't care about. The OH minus I do care about. And these all break up. And again, if I had 5 of these, I would know I had 5 OH minuses. So when I found the molarity of the new solution of the whole thing, I also found the molarity of the OH minus. Negative log of that answer gives me a P number, in this case POH, because I used OH minus. And 14 minus the one you know, that answer there gives you the other version. So what's the pH and POH if you add this acid and yet more acid? Well, again, what do we need for pH? We need the molarity of the H plus. So I need moles and liters. Well, they told me the overall liters, so I just borrowed that right down here. What I don't have is the moles of H plus. And here's the trick to this one. You're adding some H plus and then more H plus, acid and acid. So if you add in some H plus and then more H plus, the amount of H plus adds up to more H plus. So what we're going to do is find the moles from the first one and the moles from the second one, and they add up. They don't cancel out, they add up. If you put in some green food coloring and then more green food coloring, the concentration adds up and the solution gets darker, doesn't it? So we're going to take the grams, find the molar mass, divide, that gives me moles of HCl, but let's mentally cross out the Cl minus because it won't matter for this. And we're just going to use that number for H plus. Grams of nitric acid divided by molar mass gives me moles of the whole thing, but let's just call it moles of H plus. These add up. We did that so we could put it here. That divides out to molarity. And negative log of molarity of H plus is pH. And 14 minus that one gives you the other one. 19 gets a little complicated. Read it over. And what I said here is pH 7 to pH 4 is a change of pH 3, which is a change of 3 decimal points in H plus molarity. H plus goes from 1 times 10 to the negative 7, which is go with that, to 1 times 10 to the negative 4, which would go with that. Let's say 1 times 10 to the negative 7 is inconsequential compared to 1 times 10 to the negative 4. We need 1 times 10 to the negative 4 for the H plus molarity from the acid. So we need 1 times 10 to the negative 4 molarity H plus from the acid. pH 7 means that the molarity of H plus is 1 times 10 to the negative 7, which is this very small number. I want to change everything to pH 4, which is the molarity of H plus being 1 times 10 to the negative 4, which is this number, which is a lot bigger than that one. In fact, this is 1,000 times bigger than that one. And that means a very important point. We can do a little bit of a cheat. I need to take this and add some number such that I achieve this. And here's a concept that comes up in the AP class all the time. If this number is too small to notice, then you won't notice and we'll skip it. Let's call that 0. So now I have 0 plus something equals that. So you know what I need to add? I need to add that. And honestly, you wouldn't notice. So let's not bother. The molarity of the H plus that I need from the acid is this. To be extra picky, really it's this minus whatever that is, but that's too small to notice, so forget it. We're just going to say the molarity we want to achieve is this from the acid alone. Molarity is equal to the moles divided by the liters. The liters is 1 million, which is 1 times 10 to the 6th liters. When I solve for x, I do this times that. 1 times 1 is 1. When we multiply scientific notation numbers, we add the exponents on 10. So we get 6 plus a negative 4 is a positive 2. This is 1 times 10 to the 2, or 100 moles. Then I can convert that to grams. Also, I realize this is a little bit weird because actually HCl in its pure form likes to be a gas. And anyway, it's just a practice problem, so we will measure it in grams.